to see the students of 12th standard. Important topic of this chapter, it is self-inductance. स्टूडेंट्स ध्यान रखें, जहाँ पर मैं ये स्केल रख के पढ़ता हूँ वो अच्छी तरह से वर्ड्स आप सुने. कभी कभी शायद बोर्ड पे ना भी दिखाई दे, लेकिन आप ध्यान से सुनोगे तो आपको समझ में आएगा कि ये वर्ड्स में कौन से स्पीक आउट कर रहा हूं. तो हियर a question can be asked like this one. Write a short note on self inductance. As you can see, this is a diagram. This is a one conducting coil connected with battery, key and rheostat. So rheostat is a device on which there will be a one slider that can be moved from left to right, and as you move it, accordingly this resistance of the circuit change, and as the resistance of the circuit change, the current coming out from this battery will also change. So in this circuit there is not a constant current, but there is a varying current, changeable current, and this changeable current can be done just by moving the slider of rheostat. Until you move it, the current will change. If you don't move the slider, keep it on fixed position, the current passing through the circuit remain constant. So here, important point is that of movement of slider. So you can change the current, and as you will change the current, then here the magnetic flux linked with this coil will also changes. And this kind of the change allowed to be done with the coil with itself. And that's why whichever the EMF will produced in this coil due to change of magnetic flux, then it is known as what? The self-induction phenomena. So let us see the words are here. The phenomena in which the EMF is induced in a single isolated coil due to the change of magnetic flux through the coil. And ये change of magnetic flux किसकी वजह से? By varying the current through the same coil is called what? Self-induction phenomena. तो यहाँ पे current flow रहा है through the coil से, तो along the direction of axis magnetic field generate होती है. वो magnetic field allowed to be linked with each turn having the area equal to pi r square. So magnetic flux is linked with each turn. If there are n turns, then magnetic flux linked with entire coil is, as you know, magnetic flux equal to BA, then for entire coil it will be NBA. That NBA matlab you can write N phi. Phi is the symbol of magnetic flux linked with each turn, equal to B into area of the coil, and NBA is the total magnetic flux, or you can say N phi is the total magnetic flux linked with this coil, and this total magnetic flux linked with the coil is also be known as a flux linkage. And this magnetic flux linked with a coil of N turns, or you can say the flux linkage, is directly proportional to the electric current passing through the coil. So one can write N phi B is proportional to I. As the value of current I increases, N phi B increases. As the value of current I decreases, N phi B decreases. So by changing the value of current passing through this coil with the help of this rheostat, you can change the magnetic flux. And as there is a change of magnetic flux, according to Faraday's law, and induce the EMF generated between the two ends of this coil. And this induced EMF generated in the coil only because of current passing through the coil itself, current changing passing through the coil itself is known as what? Self-induced EMF. And this phenomena is known as what? Self-induction phenomena. So here N phi B is proportional to I, therefore N phi B is equal to capital Li, where capital L is proportionality constant, and it is called self-inductance of the coil. When current is changed, the magnetic flux linked with the coil also changes, and EMF is self-induced EMF produced in the coil between its two ends. According to Faraday's law, this self-induced EMF equal to minus d by dt of flux linkage, that is n phi b. But n phi b equal to what? Li. L is constant, so here self-induced EMF is minus L into di by dt. So what is the equation of self-induced EMF? Equal to minus L into di by dt, where minus sign due to Lenz's law, and this self-induced EMF is also being known as a back EMF. Why it is called the back EMF? Because it opposes any kind of change of current, matlab any kind of increase of current or any kind of decrease of current. That's why it is known as back EMF. So as it is happening in friction, if the car is moving on a smooth road, there is no friction. But if the car is moving on a rough road, then roughness of the road, which will opposes the motion. The same thing is here be happening. So this kind of the self-induced EMF produced between two ends of the coil opposes. किसका oppose करेगा? The increase of current या decrease of current passing through the coil. And that's why this self-induced EMF is known as the back EMF. So self-induced EMF is also called the back EMF because it opposes any kind of change of increase of current in a coil or decrease of current in a coil. Then we define the self-inductance by taking the ratio of n phi b and current I. So L will be equal to what? N phi b upon I. So self-inductance of a coil is defined as, तो n phi b is what? Total magnetic flux. अब अगर ये टोटल मैग्नेटिक फ्लक्स 1 एम्पियर करंट पास कराने से मिलता है तो उसको खुद को क्या कहेंगे? टोटल मैग्नेटिक फ्लक्स विल बिकम सेल्फ इंडक्टेंस. तो सेल्फ इंडक्टेंस ऑफ ए कॉइल इज डिफाइंड एज द टोटल फ्लक्स लिंक्ड पर यूनिट इलेक्ट्रिक करंट, बिकॉज L इक्वल टू n phi b अपॉन I, टोटल फ्लक्स अपॉन करंट. करंट की वैल्यू 1 एम्पियर ले लीजिए, तो 1 एम्पियर करंट पास कराने से जितना भी मैग्नेटिक फ्लक्स लिंक होता है विद द कॉइल के साथ, दैट विल बी नोन एज सेल्फ इंडक्टेंस. देन दिस सेल्फ इंडक्टेंस के लिए अगेन अकॉर्डिंग टू दिस इक्वेशन E इक्वल टू माइनस L इंटू डी आई बाई डी टी. सो यू कैन राइट L इक्वल टू E अपॉन माइनस डी आई बाई डी टी विथ नेगेटिव साइन. लेकिन नेगेटिव साइन नहीं लिखते हैं तो भी यहाँ पे डेफिनेशन में चलेगा. तो L इक्वल टू E अपॉन डी आई बाई डी टी. तो डी आई बाई डी टी को क्या कहेंगे? रेट ऑफ चेंज ऑफ करंट. di by dt is 1 ampere per second. मतलब क्या कि with the help of rheostat, in a 1 second you are moving the slider of rheostat so that the current either increases by 1 ampere or decreases by 1 ampere. Then it is stated the rate of change of current is 1 ampere per second. And ये rate of change of 1 ampere per second की वजह से between two ends of a coil, यहाँ पे अगर आप वोल्ट मीटर लगा दो तो वोल्ट मीटर का वोल्टेज का रीडिंग जितना भी मिलता है वो क्या कहेंगे? Self-inductance of a coil. So here, if di by dt is 1 ampere per second, then L is equal to E. मतलब क्या? Self-induced EMF produced पर इसकी वैल्यू कितनी है? 1. तो इसको क्या कहेंगे? Per unit rate of change of current is called the self-inductance of a coil. So there are two definitions. We remember. Then what will be the unit of self-inductance? The unit of self-inductance is a Henry in the memory of the scientist Joseph Henry. It is known as Henry. So what will be this Henry? So you can determine from this formula unit of L equal to unit of E upon unit of di by dt. So unit of E and voltage measured in volts, di by dt is measured in ampere per second. Second ऊपर आएगा तो वोल्ट सेकंड पर एम्पियर, यानी हेनरी इज इक्वल टू व्हाट? यू कैन राइट वोल्ट सेकंड पर एम्पियर. अकॉर्डिंग टू दिस यू कैन राइट Henry is equal to unit of flux upon current, and unit of flux is Weber. So Weber per ampere is also be known as Henry, or volt second per ampere is also be known as Henry. And dimension formula using this one you can determine m1 L square t raised to minus 2 e raised to minus 2. Now this self inductance of a coil depends on what? According to this formula, L is equal to n phi b upon I. तो फाई क्या है? मैग्नेटिक फ्लक्स. एंड मैग्नेटिक फ्लक्स इक्वल टू क्या होता है? मैग्नेटिक फील्ड इनटू क्रॉस सेक्शनल एरिया. यानी कि ये क्रॉस सेक्शनल एरिया कॉइल का ज्यादा है मतलब इसकी साइज ज्यादा है तो आपको मैग्नेटिक फ्लक्स ज्यादा मिलेगा, सेल्फ इंडक्टेंस ज्यादा मिलेगा। डिपेंड्स ऑन एन नंबर ऑफ टर्न्स, 2-3 के बदले में बहुत सारे हैं तो भी एल की वैल्यू बढ़ेगी। एंड इनसाइड दिस कॉइल विच मटेरियल यू आर कीपिंग, वेदर इट इज एयर मीडियम और इट इज एनी अदर मैग्नेटिक प्रॉपर्टी material medium is there. So depending on medium also you have the value of self inductance. So this self inductance of a coil depends on size and shape of the coil. Circular shape है या square shape है या rectangle है, आगे का इसका क्रॉस सेक्शन एरिया, साइज कैसी है, बड़ी है या छोटी, शेप कैसा है, इसके पर भी डिपेंड करता है। तो साइज एंड शेप ऑफ ए कॉइल, because depending on size more be the area or less be the area, depending on shape also you can have the value of area. Then number 2, it depends on number of turns, capital N पे depend करता है। and number 3 depends on magnetic property of the medium of the coil. अगर इसी coil के अंदर आयरन भर दिया जाए, सॉफ्ट आयरन भर दिया जाए एंड फिर इसका सेल्फ इंडक्टेंस फाइंड कर दिया जाए तो आपको इसका सेल्फ इंडक्टेंस ज्यादा मिलेगा, बिकॉज कंपेयर टू एयर मीडियम द सॉफ्ट आयरन हैज मोर विद द मैग्नेटिक प्रॉपर्टी। सो मैग्नेटिक प्रॉपर्टी ऑफ मीडियम विद इन द कॉइल कौन सी है उस पर भी डिपेंड करता है। देन you can have the definition of inductor, जिस तरह से resistor की definition है। What is resistor? A circuit component which has a resistance is known as resistor, and resistance is measured in ohm. Inductor तो इसी तरह से resistor की तरह inductor है। inductor किसको कहते हैं? इस प्रकार की ये जो coil है उसको inductor कहते हैं। मतलब क्या? The component of a circuit as per example coil which possesses self inductance is called an inductor, and circuit symbol of inductor is like this one. Then the end of a inductor through which the current is entering is considered as positive, and another end through which the current is coming out is considered as negative. So be remember, just like a resistor, this is a second circuit component which can be used in electricity. It is inductor. This inductor is just like a capacitor also, as you studied. What is in capacitor? In capacitor there are the two plates, metallic plates, and between them there will be the air medium is there, बराबर। तो जिस तरह से कैपेसिटर है इसी तरह का ये इंडक्टर है। कैपेसिटर में इन द रीजन बिटवीन टू प्लेट्स, ये पॉजिटिव चार्ज प्लेट, ये नेगेटिव चार्ज प्लेट, तो वहां पे इलेक्ट्रिक फील्ड होती है और यहाँ पर थ्रू द इंडक्टर में से इलेक्ट्रिक करंट पास कराने से मैग्नेटिक फील्ड होती है। तो बी रिमेंबर, दिस इज ऑल्सो एन इंपॉर्टेंट कॉम्पोनेंट इन इलेक्ट्रिसिटी, इंडक्टर। Now as you know, in capacitor there is a electrostatic potential energy stored due to presence of electric field. Similarly in inductor, due to presence of magnetic field, the magnetic potential energy stored. So now we derive an equation of magnetic potential energy stored in inductor. So here, as we have seen in earlier topic, there was a circuit symbol of inductor, that means a coil. And now suppose at any time t in this inductor or in this coil, I is the current flowing, and with the help of motion of the slider of rheostat, the current can be increased or decreased. So you can say the rate of change of current is in inductor is supposed to be di by dt. Then the magnitude of the induced EMF generated between two ends of a coil, that was self-induced EMF between two ends of a coil. We have seen that capital E equal to minus L di by dt, but we are considering at present magnitude, so modulus of E equal to L into di by dt. But as I have discussed earlier, this self-induced EMF is also called the back EMF. Why it is called back EMF? Because it opposes any kind of change of increase of current or decrease of current in the circuit or in the coil. तो इस तरह से यानी कि ये बैक ईएमएफ जनरेट होने के साथ ही अब अगर आप स्लाइडर को मूव करा के करंट इंक्रीज करना चाहते हैं या करंट डिक्रीज करना चाहते हैं, तो ये इंक्रीज या डिक्रीज ऑफ करंट का क्या करता है, ये सेल्फ इंड्यूस्ड ईएमएफ ऑपोज करता है। एंड ऑपोज करता है इसीलिए अब यहाँ पे ये करंट की वैल्यू 2 एम्पियर से 5 एम्पियर, 6 एम्पियर, 10 एम्पियर बढ़ानी है, तो इसके लिए आपको वर्क करना पड़ेगा अगेंस्ट दिस बैक ईएमएफ। So the work is needed to be done against the back EMF in establishing the current value I. 0 से 10 एम्पियर करना है तो 0 से 10 एम्पियर का वैल्यू के लिए आपको क्या करना पड़ेगा, वर्क करना पड़ेगा किसके अगेंस्ट में, अगेंस्ट द बैक ईएमएफ। एंड ये जो बैक ईएमएफ के अगेंस्ट में वर्क करेंगे, दैट वर्क इज गोइंग टू बी स्टोर्ड इनसाइड द इंडक्टर इन द फॉर्म ऑफ magnetic potential energy. Magnetic potential energy. As you know the concept of simply potential energy. What is potential energy? The amount of work done in lifting a body from ground to the certain height h, which will be the work is done against the gravitational force. So that work is stored in the bucket in the form of gravitational potential energy. But here the work is done against the back EMF, against the self-induced EMF. That's why that work is stored inside the inductor in the form of magnetic potential energy. So this work is stored as the magnetic potential energy in the inductor. अब यहाँ पे मैग्नेटिक पोटेंशियल एनर्जी की इक्वेशन कितनी, तो वी ऑब्टेन, मान लो आपको करंट 0 से I एम्पियर करना है, तो फॉर द करंट ऑफ I एम्पियर एट एनी इंस्टेंट इन द सर्किट द रेट ऑफ वर्क डन इज dw by dt. तो रेट ऑफ वर्क डन dw by dt इक्वल टू क्या होता है, इलेक्ट्रिक पावर, एंड इलेक्ट्रिक पावर इक्वल टू क्या, वोल्टेज इनटू करंट. सो मॉड्यूलस ऑफ इंड्यूस्ड ईएमएफ इनटू करंट. Therefore this dw by dt equal to modulus of induced EMF is L into I di by dt. तो I इसके साथ Li into di by dt, दोनों साइड से dt कैंसल, तो dw equal to Li into di. लेकिन आपको तो करंट 0 एम्पियर से I एम्पियर करना है, तो इसके लिए टोटल वर्क चाहिए. तो यहाँ पे क्या हुआ, दिस dw is little work done in order to increase the current by di ampere. In order to increase the current by di ampere, that is a small change of current है. लेकिन आपको ज्यादा large change of current करना है 0 से I. So total amount of work done in establishing the current I from 0 value is W equal to integration from 0 to I of dw. यहाँ पे dw की वैल्यू पुट करें तो 0 to I का इंटीग्रेशन ऑफ Li into di. तो इसका इंटीग्रेशन में L is constant, तो I di का इंटीग्रेशन I square by 2, तो you will get it is 1 of Li square. And this amount of work done is known as magnetic potential energy. You can also write the symbol of magnetic potential energy as U equal to 1 of Li square, or you can write simply with the W is the symbol of magnetic potential energy. So thus the electrical energy required, यानी कि electrical energy required to build up the current I from the battery in the circuit is W equal to 1 of Li square, or it is called magnetic potential energy. Now this equation 1 of Li square is similar to what? Equation of kinetic energy in classical physics 1 of mv square. तो अब यहाँ पे इस इक्वेशन में m क्या है, m is mass of the body. अगर बॉडी का मास ज्यादा है एंड मूव करती है विथ वेलोसिटी ऑफ v इक्वल टू 10 मीटर पर सेकंड की स्पीड से, तो इसकी काइनेटिक एनर्जी ज्यादा होगी. अगर इसका मास कम है तो मूव करेगी विथ वेलोसिटी ऑफ 10 मीटर पर सेकंड, तो इसकी काइनेटिक एनर्जी कम होगी. लेकिन ये मास का रोल कैसा है, तो मास इज इनर्शियल मास. अब इनर्शियल मास क्या करता है, इसके ऊपर कोई भी आप फोर्स लगाओ तो इसका ऑपोज करता है. अब ज्यादा मासी बॉडी है तो फोर्स लगाएंगे तो आपको बहुत ज्यादा फोर्स लगाना पड़ेगा, क्योंकि इसके पास इसकी जो मटेरियल प्रॉपर्टी है वो मटेरियल प्रॉपर्टी ऑफ फोर्स का ऑपोज करता है. दैट्स व्हाई इट इज नोन एज व्हाट, इनर्शियल मास. तो सिमिलरली तो यहाँ पे दिस इक्वेशन एंड ये इक्वेशन का सिमिलरिटी कहता है m is similar to that of L, v is similar to that of I. यानी कि in mechanics linear velocity v is correlated with electrical physical quantity electric current I. Similarly here in mechanics mass of a body is similar to that of L. So L is similar to that of a mass, but mass m is property of inertia of a body. So L is called electrical inertia, and it opposes the growth and decay of current in a circuit. तो वो क्या करता है, सर्किट में जो करंट इंक्रीज करते हैं या करंट डिक्रीज करता है इसका ऑपोज करता है. तो इट इज इलेक्ट्रिकल इनर्शिया. तो L is called electrical inertia and it opposes the growth and decay, यानी कि ग्रोथ में बढ़ना, decay मतलब कम होना of current in the circuit. Now there is a one little bit small example is there. calculate the self-inductance of a solenoid, long solenoid, having a length is smaller. Its length is very, very large compared to its radius. Then it is called a long solenoid. Having cross-sectional area, capital A, is supposed to be equal to pi r square, and small m with the number of turns per unit length. नंबर ऑफ टर्न्स पर यूनिट लेंथ मतलब इसका टोटल नंबर ऑफ टर्न्स कैपिटल n है एंड इसकी लेंथ स्मॉल l है. मान लो n इक्वल टू कैपिटल N इक्वल टू 1000 एंड l इक्वल टू 50. तो 1000 अपॉन 50 दैट मींस 100 अपॉन 5. 100 अपॉन 5 बिकमिंग 20. तो 20 आर व्हाट नंबर ऑफ टर्न्स पर यूनिट सेंटीमीटर लेंथ. 20 सेंटीमीटर नंबर ऑफ टर्न्स किसमें विद इन 1 सेंटीमीटर में. Then small n is known as what? Number of turns per unit length, is total number of turns upon its total length. So for such a solenoid having length small n, cross sectional area capital A, and small n with the number of turns per unit length, calculate self inductance. तो कैसे सेल्फ इंडक्टेंस फाइंड करेंगे? जो आगे का डायग्राम था उस चीज का. सेल्फ इंडक्टेंस के लिए L इक्वल टू n phi b अपॉन I चाहिए. मतलब आपको इसमें से इलेक्ट्रिक करंट I पास कराना है. And as you pass the electric current through such a coil along the direction of axis, magnetic field is generated. Due to magnetic field, with each turn, the magnetic flux is generated, and that magnetic flux is equal to what? B into A. And अगर इसके total number and this magnetic flux linked with every turn will be same, and n with the number of turns, so इसका total magnetic flux will become what? NBA. That is the, you can write instead of BA phi. So phi is equal to BA is magnetic flux linked with each turn. So total flux linked with this, यहाँ पे due to current I flowing through the very long solenoid, magnetic field produces along its axis inside the solenoid is B equal to, as you know, mu 0 small n capital I. And this magnetic field की वजह से total magnetic flux linked is n phi b. And as it is, and phi b is magnetic flux linked with every turn is B into A. And here according to this equation, what will be this capital N? Capital N will be equal to small n into L. So small n into L. And B equal to mu 0 Ni as it is, capital A as it is. So n phi b equal to mu 0 n square I A into L. Of self inductance according to definition, total magnetic flux upon electric current. Total magnetic flux upon electric current. तो mu 0 n square IE upon L upon I equal to, here II is cancelled, so mu 0 n square AL is the equation of self inductance of a coil due to electric current passing through. And this self inductance, now you see, does not depend on current. Mu 0 n square A into L. And if soft iron having a magnetic permeability mu r is filled inside the solenoid, then its self-inductance increases by mu r. So you can write the self-inductance of such a solenoid inside which the soft iron is placed. Then it is mu r times mu 0 n square into L. After this, we will study about the mutual inductance.